Okay, folks, this is the video tutorial for the homework one, specifically for Lab 53, which is meeting on Mondays, 4 p.m. to 6:50 p.m. And in this uh, assignment, homework one, you're asked to upload or submit only problem number one. There's two of them. I will do both, but for marking purposes, it's problem number one for you guys. Now, here's the problem. This is a part made out of steel, right there, steel, okay? And the dimensions are given. The inside of the hole is fixed, clamped, okay? And these two edges, AB and CD, are subjected to a force. And this is really not a concentrated force in the middle. On that edge, entire edge AB and entire edge CD, there is a total force of 500 pounds that's applied. Now, notice that it says, make sure that mesh around the hole, first of all, is finer. Okay, we're going to do that. And make sure all planes of symmetry are taken into account. Okay, so you have to decide what part of the minimum part of the model that you minimum uh, geometry of the part you can model so that you get the necessary results to uh, solve this problem. Now, this is more like a staring at it and some common sense. You just look at this 500, 500 in the same direction. The geometry is symmetric. So it makes sense that to say that there is a plane of symmetry which is cutting that parallel to the YZ plane. No doubt about it. And then again, you look at it, stare at it, you see that, oh, maybe there is also a plane of symmetry if I cut this thing parallel to XY plane, like this. And the answer is yes. These planes of symmetry, identifying planes of symmetry, is a major part of your mark in the final exam, okay? And the only way is to, look at different problem, pay attention to what I'm doing in the lectures, etc., and you get the hang of it. Okay. Now, by the way, this is very important. You have to do something about this load later on. You'll see that. Now, problem number two is exactly the same geometry. The only difference is that the force is applied on these two edges. On AB is up, and on CD it's down. Now again, you look at the common sense. This thing, if you apply a load like that, this thing will actually twist. If it's twisting, then there is no plane of symmetry. In the other case, we were pushing this thing along the y direction. Same force, same location, along the y direction. So it made sense that in the previous case, problem one, to set that yz and xy are planes of symmetry, but not here. Okay. Now, you have two choices when it comes to a problem like that. Make the whole part and then cut it with the appropriate planes. Or if you know what the answer is going to be as far as the planes of symmetry, make the portion of the part that is really restricted to that piece that you're trying to model. What I will do, I will model the whole thing, and I will cut it with the appropriate planes so that you get basically one quarter of that, I think. All right, so let's go out here. At this point in the course, you're only doing analysis of parts. Therefore, do not start with product. Start with a part file. Here's a part file. Okay. Now, I will leave this thing. Let me do the following. Let me change this thing properties. Let me change this thing to call it part instead of part one. Okay. All right. Immediately you save it. So you go File, Save Management, Save As. On the desktop, I create a folder and the name of that folder is homework one, lab 53. Lab 53. So I'm going to put anything that I do on this particular lab, in this particular homework, in this lab, in that folder. Now, is this the name that I want to call it? No, I want to call it a name that it never gets confused with another part if I ever have to do that. Because remember, when I go to problem 2, I will make another part, okay? And if they're both called part in that folder, it's going to overwrite the other one. This is one of the biggest sources of losing points on midterm and final, because you overwrite your other parts that you didn't mean to. So I'm going to call it like this: homework 1, problem 1, uh, give it my name, and I don't have to do anything with this last portion, even if it was not there. The name of the part is identified by the first portion here, okay? Now here part is added to the end, which is fine. It could have been part 1 was added, but this is how you identify your part. Homework 1, problem 1. Okay, so say okay. And if you go and check your desktop, there's the folder that I created, and this is the part that I saved in it right now. Okay, so now we're going to make it. On this vertical plane, I will sketch. Now, if I had to do this thing myself, I would actually go ahead and draw that section, and by section I mean uh, this piece, okay, this section. I would do it so that it is, when I create it, the XY is a plane of symmetry, because I know that I have to cut it with the XY, right, with the XY plane. But on purpose, I'm not going to do that. By the way, I want the grid to show up here, so let me see if I can find the grid right there. Yeah, where's the grid? Oh, there. Okay. Now, so the first thing I'm going to do is to draw a line. This is going to be a construction line. I'm not going to use it for anything else, but it's a construction line. A construction line, you select it, and then let me get this thing out of the way right there, and that makes it into construction line. See that? A construction line. Okay, now I'm going to try to do that section that you saw. So here's how I'm going to do this. Move this thing out of the way. So something like that. I didn't want this thing to be construction line, so I have to fix it like this, like that. And I really didn't want this to be construction, so I select all of these, this, and that guy. Oops, control. Okay, and turn it into an actual line, not a construction line. Now, the other thing is that I want this construction line to be the plane of symmetry of these two lines. So one way, for example, you give it dimension, just like what is in your homework. From here to here is 4. From here to here is 4. But I like a different way of doing these things with minimum dimension. So that line control this line. See the top, the bottom. Control middle line, the thing that I want to make it symmetric. And I click on this icon, see that? It says constraint defined in dialog box, and I'm going to make it symmetric. So what it does, without me actually saying this is 4 and this is 4, so they're the same, I selected the top, the bottom, the middle, and said symmetric. Okay, very good. Now let's dimension. So the dimensions that are given, actually let me draw the circle here. We need a circle there. There's a circle. And these, by the way, they are concentric, so I was careful in selecting it so that these have the same center. And if not, if you're not sure, so it's like this, you control that, and you go to constraint using dialog box, and you say concentric. You see, it was concentric, that's why it didn't move at all. But that's okay, we can leave it like this. Now, the nice thing about this is that you can take this line and move it. Because you made that thing symmetric, it's going to stay like that, okay? All right, let's give some dimensions. The dimensions that I see there, this is 10 inches. I've already set up my units so that they are in inches. Okay, there we are. The radius, this big radius here is 4. This radius is 1, so the diameter is 2. Okay, that's pretty much it. Exit. Now, I can pad this, and on purpose, I'm going to pad it symmetrically in both directions because I'm doing things so that the YZ remains a plane of symmetry. If it's not remaining the plane of symmetry, you have to do a couple of more extra steps. Okay, that's fine. So we say pad it, and the thickness of that thing was 2 inches. So when it says 2 inches, 1 inch, 1 inch in each direction, and mirror extent makes it 2 inches. There we are. So what I've done here is uh, done this part. Okay, so let's go back. Okay, so let's save everything first of all. Now notice that all I did is click on the floppy because I already used the file save management, found the folder, put the stuff in the folder. So from now on, if I want to save my continued work, I just click on the floppy. Okay, now on that face, I will sketch. Okay, now I want to sketch this rectangle. Remember, there's a little piece on this, and on purpose, I do it like that and clean it up. So this line, control that line, you make it coincident. This line, control that line, you make it coincident. And this line, control that line, I make it coincident. Please, you have to understand that there are many ways of doing these problems, okay? This is how I do it. At the end of the day, you got to get your part, the right size, the right dimensions, and do FEA analysis on it. I don't care how you do it. This is how I approach it. So I'm going to dimension this. I believe that dimension here, this dimension here was 1. Okay, 1. Say okay. Exit and pad it. Now, when you pad that, that's going to be 2 inches. Look at your drawing. So that will give you 2 inches. There. Now I have to do the same thing on the other side. Of course you can move that thing and do it exactly like you did here. But the alternative is to take this pad and mirror it on the other side. Okay. Uh, Again, I leave it to you how you want to do that. Where is the mirror? So let's get the mirror here. Let's get this thing out of the way. And this is the mirror. So I want to mirror the pad, this pad, with respect to uh, mirroring element with respect to the YZ. Oh, with respect to, let me try it again. I was not paying attention when I did this. So mirror, read it, mirroring element. Mirroring element is that plane there. And the entire thing was mirrored, which is fine. There's nothing wrong with it. There we are. So this is what you have to create, one way or other. Okay, so save everything. All right, we're going to apply material to it. This is made out of steel. Your view may be different from that. Your view may look like this, okay, because you can change it so that things look different. Made out of steel. On this part, you say okay. There we are. You can go to steel, by the way, if you want to change the properties of steel. I don't want to do that, but anyway, these are default properties of steel. Okay. Save everything and get out of here. So, yeah, right. Now remember, this particular problem has 2 planes of symmetry. You have to cut it with something parallel to the YZ, and in my case, because I did a mirror XN, I can use the YZ plane, and then cut it with something that's parallel to XY. Now, I already can cut it here. See that? I already cut it with YZ, you get half of this. So let's go get the cut. Katia doesn't call it cut, it calls it split. So right there, split surface-based feature, This is the tool. This is a toolbar which says surface place feature. Split. Select that YZ plane, and you can take the side of the arrow or the other side. It really doesn't matter to me. So I keep the side of the arrow. There we are. Now, I also want to cut it with something halfway in the middle. Now, if I had arranged things from the beginning so that my sketch had XY as a plane of symmetry, I could have used it. But I didn't. That was on purpose. So here's how I'm going to do that. I'm going to make it draw a plane that basically goes through halfway point. So one way of doing this thing is the following. Make a point exactly between these 2 points, this point and that point, halfway, right there. And then make a plane which passes through that point and is parallel to the XY plane. So where's that point? Parallel through a point right there. The plane is the XY plane, and the point is this middle point that I created. And here is my uh, plane that I want to cut it with. So use a split, select that. You can take the top or you can take the bottom, and it makes no difference. So I'll take the top there. Now, notice that in this problem, if you had created that part, and if you were right, you had created this part and proceeded the finite element from this point on, that would have been perfectly acceptable too. Okay? All right. Now, the advantage of doing it this way, when I do problem number 2, there are no planes of symmetry. So what I can do is to go and either deactivate these splits or delete them. Okay? Okay, so let's do the rest of the problem. So we go to generative structure analysis. This is a static problem. Okay, change the rendering here so that you can see these things. This element, you can keep it or you can make it smaller. By the way, notice that the element is parabolic, okay, more accurate than linear. The size is this. If you want to change the size, go ahead and do that. If you want to leave it like this, fine. On the test, we will tell you to use the default size and, default size and default, for example, uh, type, but refine it in some area. Okay, so I'll keep it like this on purpose. But notice that the problem says I want a finer mesh in the whole area. So and the way to do that is you look at the model manager toolbar here. You look at the second icon from the left and expand it. There is an icon here which is local mesh size. You click on the local mesh size. It says where? Well, on that surface. And notice that as soon as I did that, it put a tiny little element here that's controlled by this number here. So let me change this thing with 0.5, 0.1. See how it looks like. See, that's fine. The only reason that you saw that very tiny number is that in the previous problem that I did for the other group, I probably used that number and it stays there, unfortunately. Okay, so we want to look at the mesh. So put the cursor on nodes and elements right there. Right click, mesh visualization. Say okay, and it shows you the big mesh and stuff which are finer in that area. To do the rest of the problem, what you need what you need to do is deactivate the mesh. Either delete it or deactivate. I don't know why you want to delete it. You can always get it back. Look, right click, activate, right click, deactivate. Okay, so let's see. Well, we know that the inside of this hole is completely clamped. You were told that. So here's a clamp icon. You select it. This is completely clamped. We know that we cut the bottom. This cut came from that plane. So this is on a roller surface. In other words, things as you were pushing that part, this points on this plane will not go up or down, stay there. So that's called a roller surface. Katia doesn't call it roller. It calls it surface surface slider. Okay. So you select this entire bottom face and this face. Do not take that. That's already clamped. And this side is also on a surface slider. So you can do it as a separate surface slider or with the same one, and we're good. Okay, now we're going to push this. Now notice that the problem says pushing it by 500. Pushing this edge was 500. But notice that this is 500 pounds and you're applying it on that entire edge, but you're taking only half of the edge. So this should be 250. The other one is actually not there, not there because it's on the side that we didn't actually model. So what you need to do is on that edge, on this edge, you apply a force of 250 pounds. So how do you apply forces? Right there. This is pressure. We don't have pressure here. This is force. On that edge, in the direction y, 250. Oh, not direction y. What I meant was, what did I do here? Oh, let's check that. You go here to load, double click on it. Yeah, there was not a number here in a minute. Okay, 250. Now that's better. And it is going to be negative, by the way. Negative. Oh, that's better. You see that? Pushing in the direction y, negative y, 250. That's why I put a minus 250. Now remember, there's 250 here, there's 250 below it. That makes it 500. The other side we are not modeling. That's because there's a surface slider here. Okay? All right. This is it. Now, very important. You already saved your model, but this thing you have not saved. And when it comes to submitting your work for the midterm or for homework, you not only have to give us the analysis part, you also have to give us the part. So you go to File Save Management, right there. This is the one that I already saved. This is the analysis file that I would like to change. So why don't I use this exactly same type of name? So save as, okay. So I called this thing homework one. What do I call it? Problem one. Problem one. Your name, my name, and analysis. Now this analysis one, it's entirely up to you. You can leave it like this, or you can just say analysis, or you can completely take the word analysis out. It really doesn't matter. What is identifying the analysis in this, because the type is the analysis type. Look, cat analysis, okay? And the problem one. And say okay. So notice that when you go to your folder, you have the part. This was the part. This is the analysis. Both of these have to be submitted. Later on, in a few weeks when you do, maybe 3 weeks when you do analysis of an assembly, there may be multiple parts and an analysis and a product. So there'll be a product file, there'll be multiple parts in it, and there will be an analysis, and all of those you have to submit. Okay, so let's go ahead and run it. It's very easy. The run, Katia doesn't call it run, it says compute. It looks like a calculator here. Always be prepared to go and fix things if the things don't work. Okay, so this is a warning about something that's not important. Just close it. That's it. So first look at the deformation. Remember, this inside hole is fixed. This is on a roller. The back is on a roller, and you're pushing this edge. So this is how it's going to look like. You can animate it. That makes sense. Everything is moving, but this piece is going to move more. You can see that because like a cantilever beam. So it's not, doesn't have much stiffness. The space is also moving, but not much compared to that. Now, if you want numbers, you go and select this guy, which is displacement. And if you want it in terms of contours and things like that, you either double click on the screen or double click on here and you say average ISO and then change the rendering to material shading. That looks better. Okay. Uh, so you can animate it here if you want. Right there, everything is moving. Now, if you want to see the mesh at the same time, so you go to this rendering, the very last one, customize, and it puts the mesh for you there. Okay, let's look at the stress, 1 meter stress. Now that doesn't surprise you because this looks like a cantilever beam, and the cantilever beam has the biggest stress when you bend it around the root right there. Now, if you say, well, wait a minute, what are these things? Because these are unrealistic stresses because you're applying unrealistic forces. How do you apply an edge force? It's impossible. It's like putting a knife there and pressing on the knife. So, yes, these are unrealistic. This is garbage, but you know how to do the problem if you're asked to do it. In general, people should not use concentrated forces because right underneath it, the stress is zero, or edge forces, like I did, okay, line forces. Because right underneath, if you look at a line, you're pressing, if you look at a knife and you press on the knife on a hard surface, you know what's going to happen right underneath at the blade of the knife, either blunts or you have a gigantic stress. So the process you have done it right, we have done it right, but the numbers don't rely uh, on it. Okay, so you have to take a finer mesh, convergence studies, and things like that. So okay, so let me. This is done. Let me save everything. It's going to save this, and then you can submit it. And I'm going to come back and do the second part of the problem, which is the other one. Let me stop this for a second. Okay, so we are done with problem number one. I'm going to close this. I already saved it. I'm going to close that. This one, I want to save it as a different part. So I go to File, Save Management. So right now it's over here, Save As, in the same folder, except that I'm going to call it problem number two. So any changes that I make to this part, which is a different part, is not going to affect the one that's already there. And what changes do I want to make? Well, I want to delete these, either delete it or deactivate it. Either way, that's entirely up to you. So let me go ahead and deactivate it and deactivate this other split. Deactivate right there. Uh, Let me see what I did here. I lost track of what I was doing. Split, that's the one that I want to deactivate. Okay, fine. Right. All right. So when I save this, it's going to be the second part that's going to be saved. Okay. We are done here, and now we're going to go to generative structure analysis. Say okay. So right away, I'm going to save this file, save management. This is the analysis, save as. I already have something in there, but that's problem one. So I select this and make it problem two. So anything that I do in this analysis file is not going to affect the first one that I did. Now, if you prefer, you can put all of these things in a different folder. It's up to you. And I'll leave it to you to decide. Okay, now let's make this thing final in that area. Let's see now, where is the, right, remember this was the model manager, second icon from left, second toolbar from left. There is the local mesh size here, and you select that. And this number that I put there is good. So if you want to look at your mesh, you put the cursor, right click mesh visualization, and notice that you have a fine mesh in this area. All right, and deactivate. We proceed with the rest of the problem. What do we have here? We have the inside of this hole is completely clamped. I don't have any surface slider conditions, because the reason I had it before is that I made a cut here and I introduced these artificial surfaces, which, because of symmetry and load. This is it. And now we're going to apply the loads. Let me see what the load condition was. This is problem number two. So this top edge goes up, the bottom edge goes down with these forces, 500 pounds up, 500 pounds down. So you have here's the distributed force on that edge in the direction Z, so this is 0, That one is 500 right there, like that. You can see it's on the edge, right? And then the same thing on this side, but that's going to go, let me see, where did I have it? On the top. Okay, on the top. Okay, so another one on this edge. The only thing is that this is a minus. Okay, so save it. This analysis is going to get saved and run it. This is going to twist, obviously. Okay, so this is the deformation. You can see that it's twisting. And deflection, average ISO. You can animate it if you want. You're not addressing the issue of is this fine enough or etc. Also, edge loads are impossible to apply in real life, and so are the concentrated. There is no such a thing as concentrated load, edge load. Okay, but you can apply. So the effect, of course, is a gigantic stress in this area, which may be not realistic. Now, this is not this is the displacement. So let's look at the one meter stress. Big stress here, big stress there. Obviously, it's not realistic. Now, I'm going to leave it the way it is because there are some issues that we have discussed these things during the lectures and the presentations in the lab. This is your homework. All right, folks. So good luck.